Hi everyone, in this lesson video I'm going to be showing you how to do numbers 7, 8, and 9 from the Unit 7 Air Test Review Day 2 packet. So let's get started on number 7. This problem should look pretty familiar because we did a problem like this in the Day 1 packet. It says solve the inequality for x where a is less than 0. This means that a is a negative number. So now let's solve for x. Remember, solving for a variable means getting that variable all by itself. And what we need to do is do inverse operations or opposites to get that x by itself. So the first thing I need to do is add 7 to both sides. And now I have ax is greater than or equal to 19. From there, I need to divide by a. But remember, we are dividing by a negative. What do we need to do with the inequality symbol when we divide by a negative? We need to switch that inequality symbol. So that means our answer is going to be x is less than or equal to 19 divided by a. X is less than or equal to 19 divided by a. So that would be the last option out of those 4 options on the right-hand column. Now let's begin number 8. Number 8 is similar to some problems we saw in Day 1 review packet. So notice that we have a linear equation for the first one and a quadratic for the second. So I'm going to be using the same process I used in the Day 1 problem. And that is, we're going to be using substitution. Because both of these equations are solved for y, so we can easily set them equal to each other. So circle the first equation, draw an arrow to the y in the second equation, and that's where we're going to be plugging the equation in for. So that means we have negative 3/2 x plus 2 equals x squared minus 11/2 x minus 10. So now we have both equations set equal to each other. Like we did in one of the examples in the Day 1 packet, we are going to try to set these up in decimal form just because it is easier to work with decimals. And because we have 2's in the bottom of both fractions, it is easy to put these in decimal form. So negative 3/2 is negative 1.5, and then 11/2 is negative 5.5. Just like we did in the previous problem from Day 1 material, we're going to get everything on one side because we want to have the quadratic equal to 0. So I'm going to be doing a couple opposite operations here. When I combine like terms there, I get negative 4. I also want to bring over the 2 by subtracting. Okay, at this point I have the quadratic set equal to 0, and I'm noticing that the b and the c values could potentially work with the x method, so that's what I'm going to try now. Remember, if you have decimals in your simplified quadratic, you want to go straight to the quadratic formula, and we did that in another problem together yesterday. So now negative 12 up top, what two numbers multiply to give you negative 12, but add to give you negative 4? Hopefully you're thinking to yourself, negative 6 and positive 2. So now let's take those numbers and put it in factored form. So we have x minus 6 times x plus 2. From there, we want to set each of those set of parentheses equal to 0. So that means we get positive 6 and negative 2 for our x values. Now we want to find our y values. So that means we want to substitute each of those x values in for one of the x's in the original system of equations. Obviously, the linear equation is easier to work with, so let's substitute in positive 6 first for the x. So we have negative 3/2 times 6 plus 2. When you do those operations, you should get negative 7. So that means our first intersection point is 6 comma negative 7. Now let's substitute in negative 2. And when you do those operations, you should get positive 5. So that means our second intersection point is negative 2 comma positive 5. Now we need to figure out what goes where. The directions say list the points in order according to their quadrants. Hopefully you remember from middle school which quadrant is which. Let me remind you. The top right-hand corner is quadrant 1, the top left-hand corner is quadrant 2, the bottom left-hand corner is quadrant 3, and the bottom right-hand corner is quadrant 4. So let's graph these 2 points of intersection to see what quadrants they're in. The coordinate point 6 comma negative 7 is located in the 4th quadrant. It would be somewhere around here. The other coordinate point negative 2, 5 would be located in the 2nd quadrant. So out of those 2 points, which quadrant is closest to the 1st quadrant? In order, well, it says right there, 1st, 2nd, 3rd, 4th. So the 2nd quadrant, the point in the 2nd quadrant, we want to list first. So that would be the coordinate point negative 2 comma 5. And then the other coordinate is in the quadrant 4, so that means we want to list that one after. So those would be the 2 points of intersection. And as you can see in the top right-hand corner, a visual, I showed this to you yesterday, a parabola intersecting with a line can intersect at most 2 times, and in this case there are 2 points of intersection. In number 9, we need to determine the solutions for the system of equations shown below, or at right. The equation y equals negative 2x plus 21 over 4 is a linear equation. And the second equation, y equals x squared minus x minus 3/4 is a quadratic, because the biggest degree is 2. So this problem is actually really similar to number 8. But the difference is this problem has more than one option for an answer, whereas the previous you just had to type in the answers. Notice the directions say select all the correct answers. So if you were doing this problem on the computer, you would check at least one of those coordinates, possibly more, depending on what our answer is. So just like in the previous problem, both of the equations are set equal to y, so that means we want to set them equal to each other. So the equation we're going to have is negative 2x plus 21 over 4. And that is equal to x squared minus x minus 3/4. And because the denominator is 4, I know that I can get really nice decimals by converting these fractions to decimal form. So to do that, you can just type each of those fractions into your calculator and it will do the work for you. So 21 over 4 is 5.25. And 3/4, hopefully you know that 3/4 is 75 cents, so that means that is 0.75. Now I want to get everything on one side of the equation. I want to set equal to 0, so that means I want to do opposite operations like I did before. So I'm going to add 2x to negative 1x. And that gives me positive 1x. And I'm going to now subtract 5.25 from negative 0.75, since those are like terms. So now the equation that I have when I combine like terms is 0 equals x squared plus 1x minus 6. Looking at this quadratic, I think that the x method might work, so let's try that. Remember, you could always use the quadratic formula if you're not able to factor. So the numbers that work here are positive 3 and negative 2. So let's write that in factored form now. X plus 3 times x minus 2. Set each of those equal to 0, so that means we get negative 3 and positive 2. We have each of our x values of the coordinates. Now we're going to do the same thing as the previous and plug in each of those x values for one of the equations that we were given in the original problem. And like before, the linear equation is easier to work with. So let's plug in negative 3 first for the x. When you do those operations, you should get 11.25. But notice in the options, there's no decimals. So that means we're probably going to need to convert that into fraction form. Hopefully you remember on your calculator, you could just press second PRB and F to D, so that's behind there. So it hopefully should convert the decimal into fraction form, and that would be 45/4. So the coordinate point of intersection for the first point is -3, 45/4. And I can find that is the fourth option. So you can either circle that or check it. Now let's substitute in +2 for the linear equation and see what y value we get. When you do those operations, you should get 1.25, and when we convert that into fraction form, we get 5/4. So the second point of intersection is at the coordinate 2, 5/4. And that would be the last option. So there you have it. We just did 7, 8, and 9 together. Hopefully it went well for you. If you haven't done numbers 1 through 6 yet, you can work on those now. And if you finish the entire packet before the bell rings, you can definitely work on the Math Excel, which is officially due tonight. So make sure you finish that.